Hello everyone, welcome to Unit 6, Lesson 7, Notes for What Goes Up. In this lesson we address the combined gas law. So we're going to review that or go over it for the first time depending on when you are watching this right now. So the combined gas law states that the relationship between pressure, volume, and temperature stays the same for a given sample of gas, where the proportionality constant K is equal to P times V over T. We can say that for every point in time that these are going to be equal to another point as long as it's the same sample of gas. So an alternate form of this would be P1 V1 over T1 is equal to P2 V2 over T2. The first three gas laws that we talked about in class, Charles' law, Boyle's law, and Gay-Lussac's law, are all derived from this one, or they all combine to give us this one. Okay, so if we take this, P1 V1 over T1 is equal to P2 V2 over T2. Across the top, we have Boyle's law. The PT law was Gay-Lussac's law. And then the VT law, where V1 over T1 equals V2 over T2, was Charles's law. Okay, so they all combine to give us the combined gas law. Go figure. Okay, so we're going to do a practice problem together. So a sample of neon gas occupies a volume, so that's a V, of 1 liter at 300 Kelvin, and that's temperature, and 1 atmosphere, so that is pressure. Our first problem asks us to calculate K. So we know that K, the proportionality constant, is equal to PV over T. So we are going to substitute in for each of those variables. So 1 atmosphere times V, which was 1 liter, divided by 300 Kelvin. So when you put this into your calculator, 1 times 1 is still 1, and then we're going to do 1 divided by 300, and you get 0.0033, and the units are ATM, liters over Kelvin. So suppose you increase the temperature to 600 Kelvin, so that's the new temperature, and decrease the pressure to 0.5 atmospheres. Does the volume of the gas increase or decrease? Now, what I would say is you don't know. Usually without a calculation. So we see that the temperature increased, so we would expect that the volume increased, right? So we increase the temperature, we would expect the volume to increase. Over here, we decrease the pressure, we would expect the volume to increase. So in this, we can actually restate this as volume should increase. But you should always calculate it to make sure. So we're going to do that now. So we have our K, or we can actually do P1 V1 over T1 is equal to P2 V2 over T2, where the P1 V1 T1 is our first set, so the 1 atmosphere times 1 liter over 300 Kelvin is equal to our 0.5 ATM times V2 all over T2, which was 600 Kelvin. And now I'm running out of room, but first I'm going to multiply both sides by 600 Kelvin. And then I'll divide both sides by 0.5 atmosphere. So that these cancel, and these cancel. And so now I'm going to do 600 Kelvin times 1 times 1. So the top is 600 Kelvin divided by 0.5 and then divided by 300 Kelvin. So I should get a new volume, so V2 of 4.0 liters. Okay, alternatively, you can rearrange the equation. So P1V1 over T1 is equal to P2V2 over T2. We've discussed this in the past, where when we have fractions, the first thing we should do is cross multiply. So P2V2T1 is equal to P1V1T2. It's going to sound like a lot. And we are solving for V2. So I'm going to divide by the other two to get rid of them. But what I do to one side, I have to do to the other. So P2T1. And so these cancel out, and I'm left with V2 is equal to all of this. So thank you for tuning in. Make sure you answer the guiding question on the bottom of page 21 and check your work for the lesson. Thank you.